So you probably think your biggest AI risk in 2026 is, well, that carefully vetted official enterprise model your company just spent millions of dollars in 18 months building.
Right, the one everyone is so proud of.
Exactly. But it is not. I mean, your actual biggest risk is the 27 different AI copilots, autonomous agents, and browser extensions your marketing team just downloaded yesterday that you don't even know
Yeah,
exist.
it's like this invisible layer of your business,
Hmm.
and it's operating everywhere, processing your most sensitive data right now as you listen to this.
Welcome to the deep dive. Today, we're taking you straight into the trenches of the shadow AI crisis and really looking at the massive, silent problem of model sprawl.
It is a massive problem.
Okay, let's unpack this. Our mission here is to tear down the abstract jargon and look at the actual plumbing of how work gets done today. We're going to break down exactly why protecting your intellectual property and, well, your brand trust hinges entirely on visibility.
Because if you can't see it, you cannot protect it. It's that simple.
Right. And we will explore the precise mechanics of how sensitive data is leaking out of your organization, plus the technical strategies to actually stop it. Then we're going to give you a fast, aggressive 48-hour sprint to gain control of all this chaos.
Which is an absolute game changer for leadership teams, honestly.
For sure. And from there, we'll walk through the 4 practical steps to discover and classify internal AI usage. And finally, we'll compare those exact 4 steps against the stringent new requirements of India's DPDP Rules 2025.
Because this isn't just IP best practice anymore.
Exactly. It's rapidly becoming a strict, non-negotiable legal mandate on the global stage. So, we have our expert here to synthesize this overwhelming stack of intelligence, vendor reports, and regulatory frameworks.
I am very glad to be here. Because this really is a fundamental shift in how risk is generated. I mean, we've moved from a world of controlled software applications to a world of autonomous, invisible reasoning engines.
Yeah, a total paradigm shift. But to fix a problem, we first have to understand the human behavior driving it. Why are employees suddenly bypassing IT at a scale we have, never seen before?
Well, to understand that behavior, we have to precisely define what shadow AI is.
Yeah.
And maybe more importantly, what it is not.
Right, because people hear the term and think they already know it.
Exactly. When leadership teams hear shadow AI, they often roll their eyes. They think, oh, we have dealt with shadow IT for 2 decades. People using unapproved apps is nothing new.
Right, like an employee using a personal Dropbox account to share a massive video file because, the corporate email server blocks attachments over 20 megabytes.
Yeah, that is classic shadow IT. It's unauthorized cloud storage or unapproved communication apps or some rogue project management board. And while that is undeniably bad for data governance,
It's definitely bad.
right, but shadow AI is fundamentally different in its underlying mechanics. Because shadow IT involves unauthorized storage or transfer. But shadow AI involves models that actively process, learn from, and retain enterprise data.
Wait, retain and process. That distinction feels crucial. Like the difference between just storing data and actively processing it. Can you break down the mechanics of that?
Think of a personal Dropbox account like a highly secure but unauthorized digital filing cabinet. You put a confidential document in there, and the filing cabinet just holds it.
Okay, so the danger is just someone breaking the lock.
Exactly. The primary danger is access control. But the cabinet itself isn't reading your document. It isn't, summarizing your legal strategy or learning the semantic patterns of your proprietary code.
Oh, I see.
And it certainly isn't using that knowledge to write a completely different document for a total stranger on the internet.
But a generative AI model is doing exactly that.
Precisely. When an employee pastes proprietary source code or a confidential legal contract into an unapproved, consumer-grade large language model, that data does not just sit inertly in a database.
It's being actively digested.
It is actively processed by a neural network. And depending on the specific terms of service of that free tier tool, your sensitive data might be retained and ingested to train future iterations of the model.
So you haven't just misplaced a file, you've actively fed your company's intellectual property into a public brain.
Yes. You are essentially volunteering your trade secrets to a competitor who just happens to prompt the public model the right way.
Man, that changes the entire threat model. And looking at the intelligence stack we have here, the scale of this sprawl is just staggering. We are talking about over 80% of employees using unapproved AI tools.
80% of your workforce. Let that sink in.
It's wild. And another study from Harmonic Security analyzed 22.4 million enterprise AI prompts. They found 665 distinct generative AI applications currently operating across enterprise environments.
665 distinct applications. And keep in mind, that number grows weekly as new models and wrappers just flood the market.
But the reality check is that only 40% of companies have actually purchased official sanctioned AI subscriptions. Meanwhile, overall generative AI traffic on corporate networks surged by over 890% in a single year.
What's fascinating here is that the terminology itself is getting messy because the problem has so many layers. To actually solve this, we need to differentiate between three overlapping phenomena hitting organizations right now.
Okay, what's the first one?
First, you have SaaS sprawl.
Which is just software bloat, right? Like too many subscriptions.
Yes, exactly. Duplicate tools and unmanaged licenses. It's the reality that employees today use an average of 13 different SaaS tools. The marketing team buys Asana, the engineering team uses Jira, HR uses Monday.com.
And nobody is tracking the corporate billing centrally.
Right. It's expensive and messy, but the data is generally siloed.
Understood. So what is the second layer?
Second, you have AI sprawl. This is the uncontrolled proliferation of AI integrations and embedded features across your approved SaaS platforms.
Wait, approved platforms.
Yes. Imagine you have a completely sanctioned, IT-approved CRM platform. It went through a 6-month security review last year. But overnight, the vendor pushes a silent software update that embeds a new AI copilot directly into the dashboard.
Oh, that is insidious.
Right. Now, that approved tool has a brand new reasoning engine that is suddenly reading all your customer interactions. And your IT security team never explicitly vetted that specific AI capability.
So the outer shell of the tool is approved, but it just grew a new brain that's siphoning data in ways you never authorized.
Exactly. You're inheriting the AI risk of your vendors without even realizing it. And then finally, you have true shadow AI.
The third layer.
Yes. These are completely unauthorized third-party AI tools, chatbots, browser extensions, and agentic platforms that employees go out and sign up for independently.
Usually using a personal email, right?
Oh, almost always. Personal email addresses or a simple Google single sign-on, completely bypassing the corporate network controls, procurement processes, and security reviews.
It's like hiring a team of contractors to frame a house. The construction company provides a whole set of inspected, safety-approved, company-issued power tools.
Right, the approved software.
But instead of using those, the workers are sneaking in experimental, hyper-powered plasma cutters they built in their home garages because they slice through the wood twice as fast.
That is a perfect visualization.
They aren't wearing safety goggles, and they certainly aren't telling the foreman they're using them. But if these garage tools are so much faster, and the employees clearly love them, the obvious question for any executive listening is why not just issue a blanket ban?
Just block it all?
Yeah. Block the domains on the corporate firewall, send out a stern company-wide memo, and tell everyone they're fired if they use unauthorized AI. Problem solved, Ray.
It seems like the logical, decisive response. It's exactly what a lot of leadership teams default to when they panic. The problem is, banning backfires spectacularly.
How does a hard network block backfire, though? I mean, if they can't reach the site, they can't use the tool.
Because human beings are remarkably resourceful when you take away something that makes their job easier. People adopt these tools when the incentives are misaligned with the controls.
Meaning what, exactly?
If the approved path to getting their work done is slow, unclear, or simply missing entirely, the work will behave like water and find its own route. The research in our sources is unambiguous on this. Nearly half of employees continue using personal AI accounts even after a formal organizational ban is put in place.
Half of them. They just ignore a direct mandate from leadership.
They don't just ignore it, they are forced to become stealthy. If you block OpenAI.com on the corporate network, they will just turn off their Wi-Fi and use their personal smartphone's cellular data.
Oh, wow. Yeah.
They'll use obscure browser extensions that mask the traffic and tunnel out of your network. They'll work from home, use a personal laptop to process the company data, and then email the finished results back to their corporate account.
So bans do not produce better governance. They just produce quieter, more dangerous usage.
Exactly. You push the behavior further into the dark.
That makes total sense. And this actually brings us to the Samsung incident from the source material, which I think is the ultimate cautionary tale of how this psychology plays out in real time.
The 2023 Samsung data leak is the textbook example of this dynamic.
Right. So for you listening, let's look at what actually happened back in 2023. You have these incredibly brilliant semiconductor engineers at Samsung. They are under massive, relentless pressure to produce, optimize, and ship.
Huge pressure.
So what do? Over the course of a single month, they start using ChatGPT to help them work faster. But they aren't asking it to write a polite email. One engineer pasted highly proprietary secret source code directly into the chat interface to hunt down a bug.
Unbelievable.
Another took an entire transcript from a confidential internal meeting and pasted it in to quickly generate meeting minutes. And a third engineer actually pasted in raw chip yield test sequences to ask the AI to optimize the hardware testing process.
3 massive, devastating breaches of highly sensitive core intellectual property executed in a matter of days.
So Samsung discovers this, and they panic. They do exactly what we just discussed. They issue a massive company-wide prohibition on generative AI tools. But the sources highlight that Samsung very quickly realized they had to reverse course.
They had to reverse the ban because they recognized the underlying truth. The engineers were not acting maliciously. They were not corporate spies trying to sabotage the company.
Right, they were just trying to do their jobs well.
They were highly dedicated employees trying to be wildly productive. If you take away the tool that makes your top engineers twice as fast without providing a replacement, you effectively destroy your own company's output and competitive edge.
Yeah, you shoot yourself in the foot.
Samsung realized that a ban is not a strategy. They had to pivot immediately and start investing in providing approved, secure, internal AI alternatives.
So if banning doesn't work, and employees are going to find a way to use these models anyway because the productivity gains are just too addictive, we really need to look at the actual fallout. What happens to a business when this goes wrong?
It's not pretty.
Because this isn't just a hypothetical, oh no, a chatbot radar meeting notes scenario. There is real, quantifiable, existential damage happening here.
We have to talk about the financial blow.
Oh.
Because the numbers in our research are sobering.
Yeah, looking at the IBM 2025 cost of a data breach report from our stack, organizations with high levels of shadow AI face a literal breach premium.
A huge premium.
The baseline average cost of an enterprise data breach is already astronomically high. But if your environment is saturated with unmanaged AI usage, it adds $670,000 to the cost of your breach.
That pushes the average total breach cost up to $4.63 million. And that is just the direct incident response cost.
It gets worse. When you look at the DTX and Ponemon Institute research on insider risk, the annual cost of insider risk has reached $19.5 million per organization.
Yeah, but what's the split there?
The truly terrifying metric is that $10.3 million of that total, more than half, is driven entirely by non-malicious actors.
Wait, $10 million from non-malicious actors?
Yeah.
That is the metric every executive needs to understand. $10 million lost. Not to sophisticated nation-state hackers in hoodies. Not to a malicious insider selling secrets on the dark web. That money is lost to well-meaning employees who are just trying to get a quarterly financial presentation done by 5 p.m.
And they carelessly paste confidential M&A data into an unvetted summarization tool they found on Google.
Exactly. That is the cost of shadow AI negligence.
But beyond the immediate financial hit of a breach, the sources point to a slower, more insidious threat, don't they?
Yes. The primary danger isn't just a dramatic hacker breaking into your network. It is the slow, quiet, invisible collapse of your data governance, which ultimately corrodes your intellectual property and destroys your brand trust.
It's a slow leak.
The harmonic security data we referenced earlier analyze exactly what kind of data is being exposed to these 665 unmanaged tools. It's the crown jewels of the enterprise. 30% of the sensitive data exposed is core source code.
30%.
22% is legal discourse. So confidential contracts, litigation strategies, and privileged communications. Almost 13% is mergers and acquisitions data.
That is unbelievable. Employees are just handing over the blueprints of the company.
When that level of highly classified data flows continuously into unmanaged models, your intellectual property is effectively forfeited to external training data sets. You no longer control who knows your secrets. The AI vendor controls them.
And that leads directly to what the sources call the traceability crisis, right?
Yes, the traceability crisis.
Break that down for the listener. What does that actually look like?
Let's fast forward to the middle of 2026. This is the nightmare scenario for any chief information security officer, chief legal officer, or CEO. You are sitting in a boardroom. An external auditor, or perhaps a federal regulator walks in.
Okay, setting the scene.
They slide a piece of paper across the desk. It might be a strategic financial decision your company made, a piece of compiled code your company deployed, or a diagnostic report your company issued. And they ask you a series of very simple, direct questions.
What are they asking?
They ask, where exactly did this output come from? Which specific AI model touched this data to generate this result? What exact data was retained by the vendor of that model?
Oh, man.
Who in your organization reviewed and approved this workflow? And critically, what specific external data sets were used to train the autonomous agent that made this final recommendation?
If you have widespread shadow AI running everywhere, you are just staring blankly at that regulator. You have no idea.
You cannot answer a single one of those questions. You are entirely blind. A lot of companies are going to wake up and realize they cannot answer basic operational questions about reasoning systems that are already operating inside their business.
Making decisions that directly affect their customers.
Exactly. By Q2 2026, those will stop being awkward boardroom questions and start becoming incredibly expensive regulatory fines and lawsuits.
It's one thing when we talk about software, source code, or marketing copy being leaked, but the risk becomes so much more visceral when we look at regulated industries. Let's examine the healthcare example from the sources.
The healthcare data is eye-opening.
57% of healthcare professionals have encountered or used unauthorized AI tools in their daily workflows.
More than half of doctors, nurses, and clinicians.
Yes, and they are using public consumer-grade versions of ChatGPT, Claude, Gemini, or whatever they can find to draft SOAP notes.
Which are highly detailed clinical notes tracking a patient's medical status.
Right. They are using them to generate diagnostic hypotheses and to synthesize complex treatment plans.
Which means they are actively processing protected health information, or PHI, through public servers.
Exactly. But wait, if these tools save a burned-out ER doctor an average of 32 minutes a day, like the sources claim, I mean, you are not going to convince them to stop just because IT sent an angry memo.
No, you're not.
In a healthcare system where emergency rooms are overflowing, 32 minutes is massive. It is the difference between seeing another critical patient or actually getting to go home and sleep. So isn't that operational efficiency worth a slight gap in governance?
Well, if we connect this to the bigger picture, in regulated industries like healthcare or finance, that trade-off is a dangerous illusion. It is a false binary.
Why is it a false binary?
Because inputting protected health information into a non-BAA covered AI tool, BAA meaning a business associate agreement, which is the strict legal contract required under HIPAA doing that, triggers massive HIPAA privacy violations.
And those fines are not small.
We are talking about fines of up to $1.5 million per violation category per year, and a single chat prompt containing a patient's medical history is a violation.
The fines alone could bankrupt a smaller clinic.
But the fines are secondary to the real risk. Using consumer-grade LLMs for medical diagnoses introduces profound clinical accuracy risks.
Because they hallucinate.
Exactly. Consumer-grade models hallucinate. They confidently invent plausible-sounding facts to fill gaps in their knowledge. If an unvetted, unapproved AI tool hallucinates a non-existent contraindication or completely misses a critical, life-threatening penicillin allergy while summarizing a dense 50-page patient chart,
And the clinician just trusts it and prescribes the medication.
you are directly threatening patient safety.
Yes.
The medical liability is astronomical.
So what is the actual answer? Because, as we established, you can't just ban it. You cannot take those 32 minutes of efficiency away from the doctor now that they have tasted it.
You are exactly right. The solution is not to kill the 32 minutes of savings. The solution is to provide enterprise-grade, tightly governed AI tools that achieves the exact same operational result, but within a secure, legally compliant environment.
The paved road.
Yes, the data must be sandboxed, the model must be covered by a BAA, and the outputs must be verifiable. The research shows that when healthcare systems proactively provided these approved, secure tools, the unauthorized use of shadow AI dropped by an astonishing 89%.
Wow, 89%. You have to meet the user where they are and give them a safe path to do their job.
Exactly.
If the cost of ignorance is intellectual property loss, massive high-pay fines, and losing the trust of your customers, we really need to get tactical about how we stop this. How exactly is this data leaking out of the building? We've talked about copy-pasting, but it has to be more sophisticated than just Control-C, Control-V, right?
Oh, it's much more sophisticated now.
So how do we plug the holes?
Let's break down the data exposure chain. It's a multi-vector problem, and you have to defend against all of them.
Vector number one.
Vector number one is the classic human-driven action we just discussed with the Samsung engineers. Copy-pasting directly into web-based chat interfaces.
Just normal typing and pasting.
It is the most common, the most human, and historically the hardest to prevent because to a lot of legacy security systems, it just looks like normal, harmless keystroke activity inside a web browser.
Right. Legacy firewalls just see a user typing text into a website. They don't know the text is proprietary code.
Vector number two is direct file uploads to AI platforms via personal accounts. An employee takes a massive Excel spreadsheet full of sensitive customer financial data, social security numbers, contact info.
Ooh.
They log into a free AI analytics tool using their personal Gmail account and upload the entire CSV file to ask the AI to find spending trends. That entire file is now living on a server you do not control.
Governed by a terms of service you never signed.
Exactly.
Okay.
Vector 3, and I know this is where it gets more technical, is API integrations and sauce-to-sauce syncing.
Explain the mechanism of how that actually leaks data.
Let's say your company uses a sanctioned, highly secure collaboration tool,
Yeah.
like Slack or Microsoft Games. An employee discovers a cool new third-party AI app that promises to automatically summarize all their missed messages while they were on vacation.
Sounds super convenient.
Very convenient. So the employee clicks install, and a prompt pops up asking to grant access to read your messages and channels. The employee, eager for the summary, just clicks yes. They have just authorized an OAuth token.
OAuth token. That is the underlying technology behind those sign in with Google or sign in with Microsoft buttons we see everywhere.
Exactly. But it is vital to understand that oath isn't just verifying their identity. It is a delegation protocol. By clicking yes, the employee is handing over an invisible backstage pass to an unvetted third-party AI service.
Oh, wow.
It's like handing out a master key to the corporate building to a contractor you have never background checked and letting them keep the key forever.
And what does that key let them do?
That token allows the AI vendor's servers to continuously ingest every single message sent in that corporate channel, syncing data back and forth automatically 24/7 without the employee ever having to copy and paste anything ever again.
So it creates an open, permanent pipe draining your internal data out to a third party.
It is an open, unmonitored, persistent pipe. And finally, Vector 4, AI-powered browser extension.
Browser extensions.
You download a helpful grammar checker, a translation tool, or a web page summarizer extension for Chrome or Edge. In order for that extension to physically function, the browser requires you to grant it permission to read and change all your data on all websites you visit.
That permission always sounded so broad to me.
It is total access. An employee installs this extension just to help them write better emails. But tomorrow, when they log into the company's highly secure internal HR portal to review employee salaries, or they log into the financial dashboard to look at Q3 revenue projections,
The extension is watching.
that browser extension is physically intercepting the page content. It is reading the document object model, or DOM, the live code of the page currently rendered on the screen.
It's literally reading the DOM.
Yes. It is essentially shoulder surfing the employee, pulling that text, and sending it back to the AI vendor's cloud for processing.
That is wild. The browser extension is literally watching everything you do on every secure internal site you visit, regardless of whether you are actively asking the AI for help or not.
Exactly. It operates at the presentation layer, completely bypassing your network, firewalls, and VPNs, because the data has already been decrypted to display on the screen.
So how do we actually lock this down? We need practical, technical strategies, not just fear-mongering. Bring the solutions. How do we stop the 4 vectors?
Strategy 1, you must deploy endpoint data loss prevention, or DLP, monitoring, but not legacy DLP.
What's the difference?
Legacy DLP looks for static file types or simple regex patterns like a string of 16 numbers that looks like a credit card. It fails completely against AI text. You need modern AI-aware DLP that understands context and destination.
How does it stop the copy-pasting?
It operates on the endpoint, the laptop itself, and it intercepts the operating system's clipboard API. It knows when someone tries to copy a block of Python code, and it knows they're trying to paste it into the specific domain of a public AI tool. It blocks the action before the data ever hits the network.
Modern DLP intercepts the clipboard itself. That is incredibly powerful. What is strategy 2?
Strategy 2, you have to ruthlessly audit those master keys, the OAuth tokens and API keys. Security teams need to deploy tools that scan the SOS environment. This is often called SOS, Security Posture Management, or SSPM.
Okay, SSPM.
These tools scan Microsoft 365, Google Workspace, and Salesforce to find and automatically revoke unauthorized third-party apps that employees have granted access to. You have to hunt down and shut off those invisible pipes.
Shutting down the OAuth pipes. Got it. Strategy 3.
We mentioned this with the healthcare example, but it applies universally. You absolutely must provide enterprise-grade, sanctioned AI alternatives. If you provide a secure corporate copilot where the data is fenced in, unauthorized use plummets.
You fight dangerous public AI with secure internal AI. Provide the paved roads so they don't drive off-road.
Exactly. And strategy 4, implement real-time coaching at the browser layer. As we discussed, hard network blocks don't work, right? Employees will just circumvent them using their phones.
So what do you do instead of a block?
You use modern browser security tools that pop up an interactive warning. When an employee tries to paste a list of client emails into an unapproved public AI, the browser pauses the action and says, "Hey, this looks like sensitive customer data. You are attempting to use an unapproved public model, which violates our data policy."
Oh, that's smart.
And then it says, "Did you know we have a secure internal AI tool specifically for this? Click here to redirect and use it safely."
That is brilliant. It's not a concrete wall, it is a detour sign. It inherently assumes the employee is just trying to do their job efficiently, not trying to be a corporate spy. It redirects them to the safe path while simultaneously educating them at the exact point of risk.
Education at the point of risk is vastly more effective than an annual cybersecurity training video. But
Here's where it gets really interesting, doesn't it? The game is changing again.
it is, because everything we just talked about, the chatbots, the browser extensions, the copy pasting that is just the first wave, we are moving rapidly beyond human speed chatbots. The next frontier, and the concept that is truly keeping security professionals awake at night, is agentic AI.
Agentic AI, autonomous reasoning agents.
Yes, this is a fundamentally different, vastly more complex risk category. Traditional shadow AI is a human being pasting data into a chat window for a single, isolated interaction.
Right.
Agentic AI involves autonomous software agents that are either deployed by employees or increasingly embedded directly into the background of SaaS tools. These agents do not wait for a human prompt. They make decisions independently.
Wait, independently?
Yes. They access data via APIs, they chain complex actions together across multiple different services, and they execute those actions at machine speed completely without human oversight.
Let me make sure I am visualizing this correctly. Instead of me asking an AI chatbot to help me draft an email, the AI agent is permanently monitoring my inbox. It decides on its own which incoming emails are important. It drafts the replies.
Yep.
It reaches out to the CRM via an API to check the customer's purchase history. It updates the CRM record based on the email, and then it hits send on the reply, all while I am downstairs getting a cup of coffee.
Yes, that is the exact workflow.
Yeah.
And from a security perspective, think about what you have just introduced into your environment. This creates a persistent, non-human identity with broad access to your core systems.
It's an employee that isn't human.
It is an operational insider that never sleeps, never takes a break, and processes data at thousands of actions per minute. Traditional data governance frameworks were built to monitor human speed, human-initiated interactions. They simply cannot keep pace with autonomous agent behavior.
Wow.
If you have unmonitored agentic AI sprawling across your network, writing to your databases and sending emails, your governance hasn't just slipped, it has collapsed.
Taking a deep breath here. When you lay it all out like that, stopping autonomous agents, running at machine speed, tracking invisible oath tokens, intercepting clipboard copy-pasting across 10,000 employee laptops, it sounds completely overwhelming.
It does?
If I am an IT leader, a compliance officer, or a CEO listening to this, I am probably sweating right now. Where does a company even begin to wrangle this level of chaos?
You do not begin with a 6-month strategy workshop. You do not form a committee to draft theoretical policies. You begin with a ruthless 48-hour sprint.
A 48-hour sprint, fast, aggressive action. Let's outline this, because the premise here, drawn directly from our source material, is that leaders need to execute a highly specific, practical diagnostic exercise to prove the severity of the problem.
Yes, because right now the biggest barrier to getting resources for AI governance is that executives do not believe the problem exists in their company. They think it's a theoretical risk. You don't know what you don't know. You need a map of reality.
But mapping the entire enterprise ecosystem in 48 hours is physically impossible.
Which is precisely why the sprint works.
Yeah.
It works by deliberately ignoring 90% of the enterprise. You hyper-focus. You narrow the scope down to just two highly sensitive domains where the risk of exposure is catastrophic and undeniable.
What are the two domains?
Customer data and source code.
Customer data and source code, the crown jewels. If those leak, the company bleeds. So what exactly are we mapping in these 48 hours? Let's break down the actual days.
Day 1, hours 0 to 24, is the technical sweep. Using whatever tools you currently have at your disposal, SaaS logs, single sign-on or SSO identity records, and network firewall logs. You are looking for OLUTH grants. You are looking for anomalous traffic to known AI domains.
Okay, that's day 1. What's day 2?
Day 2, hours 24 to 48, is the financial sweep. You look at employee expense reports.
Expense reports. That feels like, well, low-tech detective work.
It is the most practical, high-yield tactic you have. Look for individual employees expensing $20 a month to OpenAI, Anthropic, Midjourney, or specialized coding Copilots.
Oh, because they're just putting it on the corporate card.
Exactly. That is the easiest way to find entrenched shadow AI. It is hiding in plain sight in the accounting department, being approved by mid-level managers who just see a $20 software expense and stamp it.
That is incredibly actionable. So we sweep the SSO logs and the expense reports. What is the actual deliverable at the end of the 48 hours?
The goal is to generate a single-page document, just one page, a highly distilled map of the top 20 active AI tools currently in use within those two sensitive domains.
Just the top 20. And for each of these 20 tools, the sources say we need to answer 4 painfully simple questions. Question 1, what is the tool? Question 2, who is the internal owner? Or more likely, who is the employee who just started using it without asking?
Right.
Question 3, what specific sensitive data does it touch? And question 4, has security or legal ever actually reviewed it?
If we connect this to the bigger picture, the impact of this 48-hour sprint is rarely technical. It is deeply psychological.
The psychological impact on the C-suite.
Exactly. When you walk into a boardroom and hand the executive team a single page showing a list of 20 unvetted, unapproved, unknown AI systems that are currently reading core source code and accessing sensitive customer records without any formal security or legal review,
I can imagine the silence in that room.
it changes the temperature in the room immediately. It turns abstract AI governance, which sounds like a boring, expensive compliance topic, into an undeniable, urgent operational reality. It proves to the board that the perimeter is already breached, not by foreign hackers, but by internal efficiency.
It is the ultimate reality check. It forces action. But a diagnostic tool only shows you the symptoms, right? The 48-hour sprint proves you have a broken arm. It doesn't set the bone. So what is the actual permanent cure? How do we build an ongoing system to manage this sprawl?
That brings us to the core framework of our deep dive, the operational sanity check. The 4 practical steps to discover and classify internal AI tools and build lasting, resilient governance.
This is the playbook. Let's go through it. Step 1, discover and inventory.
This goes far beyond the initial 48-hour sprint. This is about establishing continuous automated discovery. As we said, you cannot govern what you cannot see.
How do we build continuous visibility, though?
You have to deploy discovery tools across multiple interconnected layers. The network layer, the sauce layer, the endpoint layer, and the browser layer. It means actively pulling browser telemetry to see exactly what extensions are active and what domains they're communicating with.
Tracking the DOM readers.
Right, it means monitoring API traffic for connections to known generative AI endpoints. And it means constantly tracking that OA token sprawl. You ingest all this telemetry and you build a living, breathing AI usage catalog.
Not just a spreadsheet.
No, definitely not a static Excel spreadsheet that is out of date the minute you save it. It has to be a dynamic, automated inventory of every AI interaction in the environment.
Okay, so we have a massive living list of everything being used. That brings us to step 2. Classify via a clear risk rating system, because not all AI is created equal. A tool that summarizes public marketing blogs is not the same risk as a tool that reviews legal contracts.
Absolutely not.
You have to classify tools by their inherent risk, not by how enthusiastic the marketing team is about them.
Precisely. And the source material defines a very clear, highly actionable 3-tier risk rating system. Tier 1 is approved.
What qualifies a tool to be approved?
It means the vendor has been thoroughly reviewed by the security architecture team. They have acceptable, legally binding data retention terms, meaning they guarantee in writing that they will not use your enterprise data to train their public models, and they have bounded, tightly controlled integrations. It operates inside a secure sandbox.
Makes sense. Tier 2 is limited.
Limited tools have significant business utility, but they carry inherent risk. They are only allowed to be used for non-sensitive data or synthetic anonymized data. You heavily restrict what internal systems they can connect to, and their usage is aggressively monitored.
Can you give an example of a limited tool?
Sure. A practical example might be a public code generation tool that developers are allowed to use to write generic boilerplate code. But they are strictly forbidden and technologically blocked from pasting proprietary core algorithms into it.
Got it. And Tier 3 is prohibited.
Unacceptable data retention terms. A poor security posture from the vendor. Unsafe or overly broad integrations. If a tool falls into this category, it is banned, blocked at the network and endpoint level, and actively monitored for attempted use.
You made a vital note earlier that this classification cannot just live in a PowerPoint presentation shown once at orientation.
A security rule that lives only in a slide deck is merely decorative. These risk classifications must be encoded into your technical controls. They must be fed directly into your AI-aware data loss prevention systems and your cloud access security brokers, or CASBs.
So the network enforces it automatically?
Yes. The network architecture needs to automatically know that a Tier 3 tool is blocked, and that a Tier 2 tool immediately triggers a security alert if personally identifiable information is detected in the payload.
Step 3, standardize integration patterns. Because as we discussed with the nightmare of OAuth tokens, improvising connections is how local convenience turns into massive enterprise exposure.
Exactly. You cannot have individual employees or even individual departments deciding how third-party AI tools connect to the central corporate database. You have to standardize the plumbing.
How do you standardize an environment that complex?
First, you cryptographically enforce least privilege access. An AI tool should only ever have access to the absolute minimum amount of data necessary to perform its specific function, and nothing more.
Okay, least privilege. What's next?
Second, you centralize your APIs. You do not let 1,000 different apps connect directly to your databases. You force them all to route through centralized API gateways or model proxy layers. Think of it like a highly secure border checkpoint.
Like a toll booth for data.
A toll booth is a great analogy. All AI traffic goes through this single checkpoint, where the payload can be logged, inspected for sensitive data, masked if necessary, and strictly controlled. Third, you utilize scoped service accounts rather than relying on individual broad user permissions.
Keep the permissions tight.
And finally, you ensure that all those OLI tokens are strictly monitored, audited, and regularly rotated.
You are building a highly structured, observable toll booth system for all AI data traffic.
Yes, you tame the wild sprawl by forcing all data into predictable, observable, defensible patterns.
Which leads us to the final piece of the puzzle, step 4. Build a cross-functional review loop. Because who actually oversees all these toll booths? We are talking about networks, API proxies, HR policies, legal contracts.
That is exactly why AI governance so often fails. AI risk is highly scattered across the organization. The security team only sees the data exposure risk. The legal team only sees the compliance and contract risk.
Right.
Engineering only sees the implementation details and the need for speed. HR sees the workforce impact and the need for employee training. If these departments operate in silos, the governance framework will collapse under its own weight.
So you have to force them into the same room.
You must create one shared cross-functional review mechanism, a governance council or a rapid review loop that includes representatives from all those domains. Before any new AI tool is allowed to touch production data, it goes through this unified loop.
So what does this actually mean for the listener? I am picturing a product manager finding a cool new AI tool that could save their team hours, and now they have to submit a 40-page PDF form in triplicate to a committee of lawyers and IT guys who only meet on the third Thursday of every month.
And if you design the process that way, you will fail immediately.
Because they will just go around it.
Because if this review loop is too bureaucratic, too slow, or too heavy, employees will simply route around it and go right back to using shadow AI on their phones. The process must be a lightweight registration and a rapid risk review. It must be designed to enable safe innovation, not to stifle it.
That's a tricky balance.
It is, but the explicit goal of the cross-functional loop is to get to yes, but safely, as fast as humanly possible.
So we have our 4 steps: discover and inventory, classify by risk, standardize integrations, and build a cross-functional review loop. This is incredibly logical, practical advice for securing an enterprise. It is the gold standard of IT best practice.
It is. But here is the critical pivot that every listener needs to internalize. In 2025 and accelerating into 2026, implementing these exact 4 steps is no longer just a best practice recommended by security vendors.
It is becoming the law.
It is becoming a strict, highly punitive legal mandate across the globe.
Let's talk about the regulatory reality, because this is where the theoretical risk meets hard legal consequences. Specifically, we are going to look at India's new privacy revolution, the DPDP Rules 2025. Now, strictly looking at this objectively, just focusing on the technical requirements of the law without getting into any of the politics around it.
Right, just the facts of the compliance. The Digital Personal Data Protection Rules of 2025. The Indian government recently notified these rules, which gives powerful operational teeth to the DPDP Act in 2023. And it's crucial to understand that this isn't just an isolated regional regulation.
It's part of a bigger trend.
Exactly. Alongside the European Union's AI Act, which begins rolling out its stringent high-risk AI rules in August of 2026, the DPDP represents a massive, undeniable global shift toward strict algorithmic and data accountability.
As we dive into these regulations, our goal is to impartially report the factual legal requirements outlined in the intelligence stack and explicitly show you how the 4 practical steps we just discussed are exactly the mechanisms you need to satisfy these new mandates.
Let's map it out. Let's take step 1, discovery, and step 2, classification, and map them directly to the DPDP rules. Specifically, Rule 3, standalone privacy notices.
Rule 3 states that data fiduciaries, meaning the organizations determining the purpose and means of processing personal data, shall issue standalone notices that explain an itemized list of the exact personal data being collected and the specific purposes for processing it.
Now, think about the reality of shadow AI. How could you possibly issue a legally binding, accurate, itemized list of what data you are collecting and why it is being processed if you have 27 unvetted AI tools and autonomous agents silently collecting and processing customer data in the background without your knowledge?
You can't. You are effectively lying on your federal privacy notice by default simply because you don't know the truth of your own network.
Exactly. You absolutely cannot fulfill this foundational legal requirement if you haven't done step 1, discovery, to build that continuous inventory. You have to know what the shadow tools are doing to be legally compliant.
That is a massive wake-up call. What about Rule 13, the rules for significant data fiduciaries?
Significant data fiduciaries, or SBFs, are entities that process large volumes of sensitive data, or data that poses a risk to electoral democracy or public order. Under Rule 13, SDFs face the absolute highest compliance burdens.
Like what?
They're subject to mandatory, rigorous annual data protection impact assessments, or DPIAs, and comprehensive algorithmic assessments to conclusively prove their systems do not harm user rights.
And that maps directly back to step 2, risk classification.
Yes, your internal 3-tier risk classification system, approved, limited, prohibited, is the exact foundational data you need to feed into those legally mandated annual DPIAs. If you aren't systematically classifying your AI risk internally, you will have no methodology to show the government auditor, and you will fail the assessment.
Wow. Let's map step 3, standardizing integrations. How does building API gateways and toll booths fit into privacy law?
That maps perfectly to DPDP Rule 6, security safeguards.
Okay, Rule 6 mandates the use of appropriate technical and organizational measures, specifically highlighting techniques like encryption, masking, obfuscation, and tokenization.
Remember when we discussed standardizing integrations using centralized API gateways, model proxy layers, and strictly monitored scope tokens? That is the exact technical mechanism required to achieve DPDP Rule 6 compliance.
Because it intercepts the data.
Exactly. By forcing all AI traffic through a proxy layer, you are building the mandatory masking, obfuscation, and tokenization directly into the architecture before the data ever reaches the AI model.
But there is a massive operational kicker in Rule 6, isn't there? The retention mandate.
Yes, Rule 6 mandates a minimum 1-year retention of all traffic and processing logs, specifically for the purpose of breach detection and forensic investigation.
And if you have an unmonitored AI agent running locally on an employee's personal browser extension, acting autonomously, you have 0 logs.
None. You're entirely blind to its traffic, its inputs, and its outputs, which means you are explicitly breaking the law. Standardized API gateways give you the central choke point necessary to generate, centralize, and retain the exact processing logs the law demands.
Mapping the final step. Step 4, the cross-functional review loop. How does an internal review committee map to a strict privacy law?
It maps directly to DPDP Rule 7 breach notification. And this is perhaps the most terrifying rule for an unprepared enterprise.
Rule 7 requires what they call dual intimation upon becoming aware of a breach. That means you must provide immediate notice to the affected users and immediate initial intimation to the Data Protection Board. This must be followed by a comprehensive, highly detailed forensic report within 72 hours.
72 hours. Now, think back to the IBM data we discussed at the very beginning of this deep dive. The average shadow AI breach takes 247 days to detect.
247 days just to realize you've been breached, and then you have 72 hours to map it, understand it, and report it to the federal government.
Yes. When an AI breach happens, the clock starts immediately.
Yeah.
You do not have time to figure out who internally owns the tool, what legal contracts or BAAs are in place with the vendor, or what HR disciplinary policies apply. You do not have time to assemble a task force.
That is why step 4, the cross-functional review loop, is critical.
Right. By forcing legal, HR, security, and engineering to collaborate before a tool is ever deployed, you proactively create the incident response muscle memory. You know exactly who to call. You understand the exact risk surface of the tool.
You've already done the homework.
Exactly. That pre-established review loop is the only way your organization hits a 72-hour regulatory deadline without descending into absolute chaotic panic.
It's about proactive alignment. You build the fire department before the house catches on fire. Before we wrap up the regulatory side, I briefly want to mention something incredibly innovative from the DPDP framework regarding consent managers. This is under Rule 4.
The consent manager ecosystem. It is a very forward-thinking approach to user privacy at a national scale.
India is establishing these independent entities called consent managers who must register with the board. They face strict financial requirements, a minimum net worth of 2 crore rupees, which ensures they are serious, solvent, highly regulated entities. But the key operational obligation is fascinating. The consent manager must ensure the data sharing architecture physically prevents them from actually reading the content of the personal data they share.
It is brilliant architectural design. They manage the cryptographic transaction of the consent, but they are technically blinded to the underlying data itself.
Which is pretty cool.
It is. If we connect this to the bigger picture of our deep dives, it perfectly mirrors the concept of zero trust for SaaS that enterprise security professionals are desperately trying to build right now. When you are architecting AI systems and proxy gateways for your business, you must build them so that the middlemen, whether that is an API connector, a third-party workflow tool, or a cloud broker, cannot read the proprietary data in transit.
The DPDP is effectively legally mandating a zero-trust architecture for digital consent. We have covered an incredible amount of ground today. Let's summarize this journey.
Let's do it.
We started with the very real, very frightening reality of having 27 unvetted AI models, rogue browser extensions, and autonomous agents silently running in the background of your enterprise, reading your DOMs and siphoning your data.
We examined the severe financial and brand risks, the $670,000 breach premiums, the $10.3 million cost of non-malicious insider risk, and the existential threat of your IP being fed into public models, rendering you blind during a regulatory audit.
We looked at the mechanics of the data leakage, the copy-pasting, the file uploads, the oath master keys, and the browser interception. And we looked at how to stop the bleed through modern AI-aware DLP, continuous SSPM auditing, and providing safe, sanctioned alternatives with browser-level coaching.
And we gave you the exact blueprint for a hyper-focused 48-hour diagnostic sprint, sweeping SSO logs and expense reports to map just the top 20 tools touching customer data and source code, providing the undeniable proof required to wake up the executive team.
And we laid out the permanent cure. A 4-step governance solution of continuous discovery telemetry, clear 3-tier risk classification encoded into your network, standardized integration patterns using API gateways, and a lightweight cross-functional review loop to get to yes, but safely.
And finally, we saw how those exact 4 steps aren't just IT best practices anymore. They are the literal technical blueprint for surviving strict new global mandates, like India's DPDP Rules 2025 and the EU AI Act.
This raises an important question, though. Where does this go next? Before we sign off, I want to leave the listener with one final forward-looking thought. It builds on that concept of agentic AI we touched on earlier.
Yeah, we have spent this entire deep dive talking about how to manage human employees signing up for unauthorized AI tools. We have been entirely focused on mitigating human behavior, human fatigue, and human incentives.
Right.
But as AI agents become fully autonomous and embedded in our operating systems, the next question you will have to answer is this: what happens to your enterprise governance when your AI agents start independently subscribing to, negotiating with, and communicating with other unauthorized AI tools entirely on their own via APIs without a human ever being involved in the loop?
When the machines themselves start causing their own shadow AI sprawl.
Exactly. The human element we discussed today is just the beginning of this challenge. The machine-to-machine shadow layer is next.
That is a terrifying but incredibly real thought to mull over as we head into the next phase of this technological shift. Thank you to our expert for guiding us through this incredibly dense, complex, and vital topic.
My pleasure. Thanks for having me.
And thank you, the listener, for joining us on this deep dive. I highly encourage you tomorrow morning, do not wait for a committee meeting. Sit down with your security team, look at your SSO logs, pull the accounting expense reports, and run your own 48-hour sprint. Turn on the likes, build your map, and see exactly what is happening inside your own walls. You might be very surprised by what you find. Until next time.